Hello, this is Jeffrey Williams, and welcome to Too Late for the Gods. William Lane Craig and his sidekick Cameron Bertuzzi recently responded to a video by Rationality Rules rebutting Craig's 5-minute cartoon presentation of his argument for God from Mathematics, which was based on a paper by Eugene Wigner. Being mired in the reductionist and trivializing nature of analytic philosophy, Rationality Rules didn't mount a very impressive challenge, and we won't deal here with his arguments. But instead, we'll focus on just a few of Craig's responses. Craig's argument rests heavily on a paper delivered in '59 by Eugene Wigner titled "The Unreasonable Effectiveness of Mathematics in the Natural Sciences" to a gathering at NYU. Craig makes claims about the Wigner paper that betray a combination of misunderstanding and distortion born of religious fervor. From this, Craig attempts an argument dependent on empty metaphysical speculation and, as always, the inevitable theist argument from ignorance, or God of the gaps. The entire Bertuzzi and Craig video lasts over an hour, but consists of no more than this above theme and several variations on the same distortions and plea from ignorance. So we'll focus on just a few statements. The entire video, however, is linked below. Before getting to the issues, Craig offers this prefatory comment.
Well, I was gratified to find a YouTube personality that is ironic and respectful in his criticism. That's the kind of person that I enjoy interacting with. And so, although I disagree with Stephen's views, I'm grateful for the charitable spirit in which he offers his critique.
Craig usually praises those who present the weakest opposition, and I proudly contrast my last video on Craig's 14 ridiculous responses to any irenic approach. Grifters and charlatans need to be exposed, and becoming one of those that Craig welcomes is nowhere on my agenda, although I would love the opportunity to debate him. Craig also went on to say that the 71,000 views to Rationality Rules video warranted a response. Again, my approach here will be different. Unlike Craig's cartoonish presentation, literally, his 5-minute video is actually a cartoon. I will go into a substantive discussion of Wigner, mathematics, epistemology, and physics. I doubt there are 71,000 people on YouTube who could even understand the Wigner paper, and I'd be happy to get 71 views from those who do. What follows requires serious attention to fully grasp, and in the next several days I will have a text version available on my blog, toolateforthegods.com. Let's start with an overview of the Wigner paper. Wigner was a physicist and mathematician of enormous importance in the development of quantum mechanics. He won the Nobel Prize in 1963 for his contribution to the theory of the atomic nucleus and the elementary particles, particularly through the discovery and application of fundamental symmetry principles. It's important to note that as a mathematician, he was a formalist, which means he understood mathematics to be inventions logically derived from reason and not ontologically connected to the physical world. He was also an atheist. His paper was delivered at an event to celebrate the 70th birthday of Richard Courant, a mathematician who emphasized the creative and aesthetic nature of mathematics rather than any practical application. From that perspective, the seeming ability of a purely rational a priori sort of game to describe the laws of nature is simply inexplicable, a wonder and mystery, and Wigner's paper was to address that mystery. In presenting Wigner as that night's guest speaker, Kurt Friedrich said, One may think that one of the roles mathematics plays in other sciences is that of providing law and order, rational organization, and logical consistency, but that would not correspond to Current's views. In fact, within mathematics proper, Current has always fought against overemphasis of the rational, logical, legalistic aspects of this science, and emphasized the inventive and constructive, aesthetic, and even playful on the one hand, and on the other hand, those pertaining to reality. How mathematics can retain these qualities when it invades other sciences is an interesting and somewhat puzzling question. Here we hope our gift will help. And indeed, Wigner went on to explore this dual nature of mathematics in the paper, and as an essentially aesthetic pursuit enjoyed by pure mathematicians through the simple elegance and harmony of proofs on one side, and practical instrumentality employed in everyday life and in physics on the other. The central question then becomes why such a subjective aesthetic enterprise should have any practical application at all in a physical world. Throughout the paper, Wigner refers to this applicability as a miracle, or sometimes as a mystery. But as an atheist, he did not mean this in the sense Craig attempts to twist it into, but rather as a dramatic effect for what seems inexplicable. Wigner resolutely refrains from offering any supernatural element to this mystery. He does, however, suggest an explanation which he subtly develops through this paper, a solution that Craig fails to grasp. Wigner starts with the beginning of mathematics as the invention of arithmetic, algebra, and geometry. This had a purely practical motivation and was based on what was observable in the surrounding environment. Numbers of goods for sale and the geometric aspects of construction were the founding drivers of these inventions. Wigner identifies these practical concerns as the first tier of mathematical thought, grounded in actual events encountered in the world. As he wrote in the paper, they were formulated to describe entities which are directly suggested to us by the actual world. This is the first ontological connection between pure mathematics and the physical world, which ultimately demystifies the approximation of math as description or reality. Its importance will come to light in just a bit. The next tier is abstraction from these practices, which gives us concepts that can be generalized. The third and highest tier is then shown to be invariability principles, which allow these concepts to be extended as laws of nature. These posit that within a limited scope of space, time, and chosen events, the observed abstractions hold as a law of nature. It is critical to understand, however, that he severely limits the applicability to the physical. For example, what appears invariable within Newtonian physics does not hold for relativity, and what appears invariable for relativity does not hold in quantum physics. We will return to this fundamental point in a moment, but first we need to also look at the aesthetic nature of mathematics, which precedes any practical function. As mentioned earlier, Wigner was a formalist who viewed mathematics as the playing out of pure reason and the faculties of the mind. While initially practical in purpose, these founding elements of mathematics were only possible as the result of turning this purely aesthetic rational faculty toward the practical through the invention of tools formed specifically by physical questions. This is the initial ontological contact and relation between mathematics and the physical world, the application of the pure concept of numbers to physical objects in the world and the logical manipulation of these numbers. The pure abstraction of mathematics is thus causally shaped by external events to answer questions of physical reality. But keep in mind, these events are exceptions to the real practice of mathematics as essentially aesthetic and unconcerned with practicality, as seen, for example, in the mystical mathematics of Pythagoras. Starting with Newton, however, the increasing demands of physics conjoined science with mathematics and fostered the invention of new mathematical tools. The invention of calculus by Newton and Leibniz, for example, was invented to quantify the laws of motion without any regard for its aesthetic qualities. From that moment on, physics appropriated mathematics as its official language. This led to the consensus among physicists that the universe itself was a mathematical construct that naturally cohered with the rational mind. To this day, many physicists naively retain this belief, which Wigner will go on to subtly amend. Now back to where we left, the issue of the limitations of invariability principles. Despite what we will see as Craig's claims to the contrary, the shifting of the time, space, and event framework results in a need for new mathematics. Not, as Craig will claim, as merely a change in new physical law, but a mathematics with new axioms contradictory to earlier invented mathematical systems. This brings us to the seminal paper by Henri Poincaré on non-Euclidean geometry, which is crucial for Wigner's paper. Poincaré demonstrated that it is possible to devise internally consistent rational systems with contradictory basic assumptions. To do so, he compared Euclidean, Lobachevskian, and Riemannian geometries, where, as Poincaré wrote, the number of parallel lines that can be drawn through a given point to a given line is 1 in Euclid's geometry, none in Riemann's, and an infinite number in the geometry of Lobachevsky. To this, Poincaré added a fourth geometry even stranger than the two non-Euclidean geometries, yet equally internally consistent. The significance of this points to Wigner's limitations on the law of invariability, where each is a rational construct which can differ from other rational constructs formed with different assumptions and chosen events. This is exactly what Wigner refers to when he asks in his paper, how do we know that if we made a theory which focuses its attention on phenomena, we disregard some of the phenomena now commanding our attention, that we could not build another theory which has little in common with the present one, but which nevertheless explains just as many phenomena as the present theory? It has to be admitted that we have no evidence that there is no such theory. Wigner goes on to refer to this as the nightmare of the theorist. That is, the existence of numerous examples of theories with elegant mathematical formulation and alarmingly accurate description of a group of phenomena which are nonetheless considered to be false. This takes us to the final crucially important element of Wigner's paper, what he calls the empirical law of epistemology. With this, he eliminates the mystery inherent in the metaphysical question of why the universe operates under the same laws as our innate reason by transforming this metaphysical question into the epistemological question of how our faculties of understanding create our representations, concepts, and explanatory systems of the universe. The answer? Our innate reason is the source of pure mathematics. 5,000 years ago, this was put to practical use, and in that process, the ontological connection was shaped by observed events, which we then abstracted to generalizations. This formed a connection between mathematics and the physical world that worked in two directions. Our innate reason provided the framework for how we intuit the world, and the events we encountered form the contents of those shapes. Through further abstraction, which is enabled through the aesthetic nature of reason, we generalized from our observed events and found we could form systematic understandings of the world that held within certain limits. It isn't a matter of a miracle coherence between the universe and our subjective reason, but rather a constructed understanding shaped by external events formed through our faculties of understanding. This enabled our ability to create modern physics. In time, this engendered the illusion of a mathematical universe. As we will see, Craig confuses this. He first claims that the immutable laws of nature and their mathematical precision, along with our innate ability to understand it, point to a divine creator. Without the claim of a mathematical universe, his argument disintegrates. Yet he later discusses the nature of mathematical understanding of physics as epistemological representation, which in fact was Wigner's point, but contradicts the belief in a mathematical world. Let's now turn to the opening of Craig's comments.
Dr. Craig is very often presented as a theist of strong intellectual stature, and I have to say, I'm someone who shares this notion. Craig has challenged me, in fact, more than any other theist I've read, but his argumentation here strikes me as jarringly poor. By assuming that the properties of the universe are built upon mathematics, rather than that mathematics is built upon the properties of the universe, Craig has put the cart before the horse. His argument is essentially a reskin of presuppositionalism, in which he's replaced the laws of logic with the axioms of mathematics. Now, to ensure that Craig's specific presentation here isn't simply a weak rendition, I've listened to him debating the philosopher Dr. Graham Oppy on this very argument, and I've digested just about every video on YouTube I can find of him discussing the topic. But I found nothing of greater substance than what's found in this short, polished presentation.
Take mystery number one, the applicability of mathematics. I think this is a huge issue.
If I'm honest, this is the kind of argument I'd expect from the likes of Frank Turek, as opposed to Craig. Because of this, I can't help but knock the feeling that I'm missing something. So if any of you think that I am, then please do let me know and I'll make another video.
Here's your opportunity.
I think he's missing two things. First, he hasn't digested Wigner's original article on the unreasonable effectiveness of mathematics. When you look at Stephen's critique, he actually has very little to say about my theistic explanation for the applicability of mathematics. Most of his criticisms are aimed at Wigner's argument that the effectiveness of mathematics in describing the physical phenomena is something that is surprising and unexpected and cries out for explanation. And so his real disagreement is primarily with Wigner, and yet he doesn't interact with Wigner's discussion of this problem. Wigner refutes virtually all of the objections that Stephen raises in the video. The presentation by Wigner is brilliant, so that anybody who wants to deal with these issues has got to digest thoroughly Eugene Wigner's original article.
It's clear we can reasonably claim that Craig has also failed to digest Wigner's paper. Craig diverts attention from his own indefensible argument to a claim that the critic's real problem is with Wigner's argument, which Craig himself fails to understand, and then the claim that Wigner has refuted all of rationality rules' objections. Craig fails, however, to tell us what the objections and refutations are. This is a typical Craig move. He rests assured that his followers are never going to read the Wigner paper, and even fewer could understand the paper. This frees him to make unsupported claims, exploiting the trust of the less educated. Craig then makes an early introduction of his God of the Gaps argument.
What Wigner is saying is that the effectiveness of mathematics in describing the physical phenomena is surprising, it's unexpected, and therefore cries out for some sort of explanation. And my argument is that positing a divine mind behind the universe is the best explanation for the uncanny effectiveness of mathematics in the physical world. So this is an inference to the best explanation. It's not presuppositionalism.
He takes what Wigner initially terms inexplicable and in literally the exact same breath concludes, then it must be God. This segment starts with a cut from Craig's cartoon, which explicitly claims that the physical universe operates mathematically. This is important because without that claim, there is no miracle to assert, although the claim is actually at odds with Wigner's paper. Maybe it's Craig whose argument is with Wigner.
Here we go.
Think about it. Mathematical entities like numbers, sets, and equations are non-physical and abstract. They can't cause anything. Yet, for some reason, the physical universe operates mathematically.
Mathematical entities such as the aforementioned are non-physical and abstract, yes, but the things they were invented to refer to are not. The earliest signs of Homo sapiens exercising mathematics dates back at least 5,000 years to the kingdoms of Mesopotamia and ancient Egypt, in which arithmetic, algebra, and geometry were employed for the purposes of trade, commerce, astronomy, and taxation. As a proponent of the non-Platonic view of mathematics known as logicism, I would thus argue that mathematics is an expression of logic that holds only so much as its axioms correlate with reality. To answer the opening question through this prism, mathematics works because that is precisely what we've designed it to do. So much so, in fact, that when it doesn't work, which is to say when it doesn't correlate with reality, we alter its axioms so that it does. To ask, why is mathematics so unreasonably effective, is to ask, why is reason so unreasonably effective?
Now, this is a self-contradictory mishmash of different positions that I don't think Stephen has thought through very well. Do you notice he says at first that he's defending logicism, that mathematics is an extension of logic? Now, logicism was a program adopted by Bertrand Russell and Alfred North Whitehead in their epical book Principia Mathematica, in which they tried to derive mathematics from pure logic, so that the truths of mathematics would be logical truths, not truths that we make up or are conventional, but they're logically necessary. And this program by Russell and Whitehead failed because mathematics involves certain existential statements, like the infinite set axiom, that there exists a set with an infinite number of members. No existential statement can be the truth of pure logic. And therefore, logicism failed to show that you could regard mathematics as simply an extension of logic. But on this view, you see, mathematics is taken to be a body of logically necessary truths. Now, that's completely contradictory with what Stephen then goes on to describe as a conventionalist view of mathematics. This is a kind of postmodernist view that is in such a minority that it's not even discussed in the little video because one doesn't have time. The conventionalist says that basically mathematical truths are just made up. They're just invented. We impose them on reality, or in Stephen's view, we simply keep revising our mathematical truths so that they will correspond to reality. And that contradicts his logicism, which regards mathematical truths as necessary truths. Moreover, what he says there in defense of a kind of conventionalist view is just patently false. The whole point of Wigner's argument is that mathematics is an a priori science that is pursued for what he calls aesthetic reasons, reasons related to mathematical beauty and excellence, whether that has any physical application or not. And in the video,
Here Craig moves to obscure the issue by focusing on logicism, which in fact is a failed enterprise, but in no way detracts from the derivation of mathematics from logic. This was not only Wigner's view, but was famously demonstrated in Kant's Critique of Pure Reason as the working of pure reason in the sensibilities of space and time. Again, Craig counts on the ignorance of his followers in his facile and false dismissal of a much larger issue. In doing so, Craig evades the stickier issue for him that logical truths are entirely dependent on premises verifiable through the senses, or else they themselves are as empty as pure mathematics and as such merely constructions. Pure reason, including mathematics, can never make existential claims, which is a defeating fact for Craig's entire metaphysical enterprise. His assertion that a God exists as an explanation is no more valid than the assertion that an infinite set exists. His criticism of logicism equally applies to his own metaphysics, and his continued God of the gaps arguments are errors of this kind. The next segment brings about, all at once, Craig's failure to understand Wigner, his own confused mishmash, and eventual undermining of his own argument. He begins by dismissing the element of invention in mathematics as a postmodern view held by a small minority. Despite the obvious fallacy of argumentum ad populum, it dishonestly characterizes the view of invention. As noted several times, Wigner also saw mathematics as invention, separate from external ontology, as Kant and most formalists did. As Wigner wrote in the paper, mathematics is a science of skillful operations with concepts and rules invented just for this purpose. Craig then attempts to make some indiscernible point by claiming that Wigner considers mathematics a purely aesthetic pursuit, ignoring that Wigner presented both the aesthetic and practical natures of mathematics and grounded the beginning of mathematics in the practical sense in the observed events.
Swatch.
First, a great deal of mathematics and science cannot be physically realized. For example, imaginary numbers and infinite dimensional spaces.
Indeed, much of mathematics can't be physically realized, and it's for this reason that while I recognize mathematics to be one of humanity's greatest tools, I do not assert that all that we can infer from its axioms necessarily exist in reality. To quote Einstein, as far as the laws of mathematics refer to reality, they are not certain. As far as they are certain, they do not refer to reality.
So my question is, where does that Einstein quote come from?
It comes from an essay on sidelights on relativity. And if you look at the context, again, of the quotation, Stephen has just misinterpreted it. It's about the different types of geometries that might characterize the physical world. And particularly, Einstein is contrasting Euclidean geometry, which is the sort of plane geometry that we all were taught in high school, with Riemannian geometry, which is the geometry of the surface of a sphere, or Lobachevskian geometry, which is the surface of a saddle. These geometries have radically different properties because of the shape of space. And what Einstein is saying is that for centuries, people were certain that Euclidean geometry was the geometry that describes the physical world. But in fact, that may not be the case. The physical world may be describable by a very different sort of geometry in which space is curved, for example. So I think that the quotation has nothing to do with Wigner's question about the uncanny applicability of mathematics to the physical phenomena, a question that Einstein himself recognized as a great mystery. We point out that many mathematical concepts like Hilbert space, which is infinite dimensional space, or imaginary numbers, which have great applicability in describing physical phenomena, cannot be realized in the physical world. These are not read off of the physical universe. So it's quite incorrect to say that mathematics is revised when it doesn't fit reality.
Perhaps Craig hoped to demonstrate that the ability of such a pure aesthetic mode of thought to describe reality is truly miraculous. However, what he claims as support is false. He then makes the preposterous claim that new discoveries in physics did not cause changes in mathematics, but merely a change in physical laws. The major problem Einstein faced in developing the theory of relativity is that the assumptions of Euclidean geometry failed to describe the newly discovered reality. As a result, Einstein embarked on the struggle to devise a new geometry which allowed for parallel lines to meet in the curvature of space, until his friend Grossman pointed out to him that Riemann had already done so. Soon after, quantum mechanics, which had no use for Riemannian geometry, reintroduced calculus to account for relative motions, but had to introduce the infinite dimensionality of Hilbert space, again, a reinvented geometry. It is also interesting that the further removed from the initial observable reality, which was the beginning of practical mathematics, the more abstract and unreproducible in reality the mathematics becomes, leading to unimaginable results such as many dimensions and superpositions, all artifacts of mathematical invention. Again, the limitations of the principles of invariability come to the fore, with relativity describing a world essentially incompatible with quantum physics, yet both mathematically internally consistent. A sure indication that reality is far different from one calculable mathematical universe. Again, this demystifies the original question in that there is no magical correspondence between mathematics and the universe, but rather various rational systems of understanding that are approximately true within limits of space-time and chosen events. Later, Craig tries to obscure his problem by again claiming the mathematic axioms never change by misrepresenting the differences between Euclidean, Lobachevskian, and Riemannian geometries as merely differing in the shapes they apply to, omitting Poincaré's demonstration of conflicting axioms that make the systems contradictory. Craig then further demonstrates his failure to understand Wigner when he claims that rationality rules has confused natural law with mathematics, when Wigner explicitly demonstrated that in modern physics, natural laws are in fact mathematical expressions.
I think that Stephen is confusing mathematics with natural laws. What happens when the natural laws prove that to be non-descriptive of reality is you revise the natural law. You get a better law, a more accurate law, but you don't revise mathematics.
Now listen to this statement and keep in mind his previous claim that the universe is mathematically knowable because of a divine creator. Afterwards, we'll listen to a segment where he contradicts this and undermines his own argument.
Scarcely anybody holds to conventionalism. You ask any theoretical physicist or mathematician as to whether the universe we live in really is describable by elegant mathematical equations, and they will say, of course it is. You wouldn't be fooling around with nuclear reactors and atom smashers if these mathematical formula didn't give you a correct description of the physical universe.
And now?
No, I think that's not right, Cameron. The point is that things like infinite dimensional Hilbert space and imaginary numbers are very useful in describing the physical phenomena. These are applicable to the physical phenomena, but that doesn't mean that the universe itself has this physical structure. Here again, Wigner's essay is so carefully argued and carefully crafted. Wigner does not say that what is amazing or uncanny is the applicability of mathematics to the physical structure of the world. He doesn't say that. He says what is uncanny and unexpected is the applicability of mathematics to the physical phenomena. And I want to emphasize that word phenomena. This is the way the world appears to us. But Wigner is not endorsing a naive scientific realism where every theoretical entity in high-level physics has a counterpart in reality. Much of the mathematics that is applicable in science is instrumental in nature rather than realistic. And the examples I gave would illustrate that. So you can't explain the applicability of mathematics by simply saying that the universe has or is imbued with a mathematical structure like this, because that's not true.
Craig is right for once. Wigner was addressing the epistemological question of why our representations approximate reality under limited conditions. This is why Wigner terms his law the empirical law of epistemology. And as Craig concedes, this does not assume a mathematical universe, only our representations of it. Without this mystical connection between reason mathematics and the mathematical world, which Craig earlier posited as proof of a divine creator, his argument from God collapses. Clearly, Craig has lost the plot here. The critical point here is that with the empirical law of epistemology, Wigner has shifted from the mystery of metaphysics to epistemology, the observable connection of the founding events of practical mathematics, the abstractions from the observations, and within the limits of the invariability principles, the determination of natural laws, which are conditioned by time, space, and the choosing of certain events, and are provisional. After having created a muddle, Craig seems to abandon Wigner entirely and attempts to return to long-discarded metaphysics in order to posit God as the answer.
Okay, here we go.
By contrast, for theists, mathematics works so well in the physical world because God has chosen to create the world according to the plan he had in mind.
Right, so according to Craig, the answer, mathematics is effective because the universe is relatively consistent, is unsatisfactory. But the answer, mathematics is effective because of God, is somehow perfectly satisfactory. God is a non-answer. It's the equivalent of because I said so. It not only doesn't answer the how element intrinsic to the why question, but it actively shuts down investigation. It stalls progress and rots the mind. When Newton's laws did not account for the trajectory of all the celestial bodies in the solar system, he invoked God, and in doing so turned his brilliant mind off. So far as he was concerned, he had answered the question, but he had not. There was a natural explanation that not only answered why, but more crucially answered how. And the answer, funny enough, required us to alter our mathematical axioms.
Did you notice any of the kind of this sounded to me almost like Peter Atkins?
Well, there's just so many things wrong with what he said, and I just want to highlight again, it did not require us to alter our mathematical axioms. What were revised were the laws of physics, not our mathematics. And what you have here is the manifestation of naturalism in a different definition. We've talked about different definitions of naturalism today. One would be the view that all that exists is space-time and its physical contents. Another would be that there are no miracles, that there are no supernatural causes. A third definition of naturalism is epistemological naturalism. And this says that our only source of knowledge is the physical sciences, and that therefore anything like God cannot be used as an explanation because it's not an extension of the physical sciences. And I reject naturalized epistemology, as do the three theists pictured in the video, Alvin Plantinga, Mark Steiner, and Michael Dummett. It is a good metaphysical explanation to posit a cosmic intelligence who has designed and created the universe. As Ed Witten said, it's as if the world were created by a mathematician. That is definitely explanatory. And it's not a science stopper, Cameron, because it's not a scientific explanation. It's a philosophical or a metaphysical explanation to a metaphysical question. Wigner's question of the applicability of mathematics to the physical phenomena is not a scientific question. And that's why for someone like Wigner, it's inexplicable. It has no scientific answer. It's a philosophical question, and therefore a philosophical answer is quite appropriate.
Once again, Craig's last gasp is the dying metaphysical breath of God of the Gaps.